So, well, basically, Dan showed you the problems, and I will show you some solutions to some of the problems. But you shouldn't just assume that the problems can be completely solved, because a lot of it is well, you just have to be always careful and check the outputs you get, whether this is really what you want, because it might be problematic. Um, well, a technical note: there is no homework assignment from today. So just basically, if you want to, you can try to voluntarily try to implement something in this area, but that's completely up to you, because basically I want to show some useful tools, libraries, approaches that you can use in practice to tackle the problems. And of course, I would like you to try out the stuff as well. So we're so we have we will look at how to do language identification, and we will look at how to do transliteration, and we will look at getting some information from about Unicode. Um, I will be showing most of the stuff using Python, or actually all of the stuff. But as Dan said and showed in the slides, there are definitely Perl equivalents, or actually a lot of the stuff in Python are taken over from Perl in this area. And for other languages, there are always some other libraries. So that's what you have to find yourself. And the first thing, let's look at language identification. Um, yeah, I'll be showing the stuff as before, and then I will make some pauses so that you can catch up if it's too fast, or if it's hard for you to try out the stuff when I'm showing it. But there will be some place for that. So for language identification, uh, there is a Perl library called langid, and a nice thing is that it's actually just one file, langid.py, so you can just download the file and use it directly without any trouble. But obviously, you can also just install it in the standard way. And well, I already have it installed. So you can just use pip to install it, or you can just download the Python file. And let's try to use it in practice. So I have, as Dan mentioned, there is a lot of multilingual data sets. And one which is easily available is the Universal Declaration of Human Rights. Here you can download a zip file with some selection of it, which is cleaned a bit. And the original is from the Unicode organization, but I will just be using a small sample of it, actually. So I will be using this filing from here called Mix of Languages, and I'll just download it. And let's see what it looks like. And so as you can see, the terminals are pretty good already, so they can show mostly fine the Unicodes. Not always. Here we see the circles which we shouldn't be seeing. So if you open it in your browser, it might even look a bit better. But anyway, so that's a file that in your worst dreams you might get something like that, which you have to process. So obviously it doesn't look like only one language. So you can try again yourself to guess what kind of languages these could be. And I guess you can recognize some of the languages easily, and some of them are maybe harder. So that's something you can guess yourself. And what I will try to do here is, let's just use a library that does the guessing for us. And remember, it's always guessing, because, well, Dan said Dan showed the problems with that. So you can often you cannot be really 100% sure about the guesses. And if you're interested how the library works, so there is a link to the paper which describes that. But basically, it's the idea of looking at the most frequent trigrams or most typical trigrams in the languages. I'm not sure exactly. So again, if this is something interesting for you, you can try to implement it yourself. It's not very hard. And I think the library comes pre-trained for 100 languages. So you can train it on your own languages if it doesn't cover the languages you're interested in. But generally, some of the most frequent languages are covered. Okay, so that was enough speaking. Let's now try to see how it works. So I will take the first sentence, so you can try to guess what language it is, and I will just pipe it into langid. And if you install it via pip, it just appears in your path. If you have the script, then just pipe it to the script. And it takes some time, and it guesses CA with some number here. So first thing is, okay, we have to somehow figure out what CA means. So either you just know it, and if not, then you should go to some Unicode lists of the Unicode of the ISO codes of languages. So there is a link here, and I have downloaded a file which just is provided like that. So there are the various ISO codes for languages, and so the result was what was the result? CA. Okay, so we can just look for CA. Okay, I should do it in a more clever way. So it's a tab, CA, and tab. Okay, and yep. So we can see that the guess is that the language of the first sentence is Catalan. Yeah, which might be. So it looks similar to Spanish, but maybe not completely Spanish. And then there is this funny number, which is kind of a score how likely it is to be Catalan. And if you ask for help for langid, so it will actually tell you that it does have some additional parameters. And one thing we're interested in is minus n. When we say minus n, it converts this very weird score into some probability. So it will tell us, well, it's Catalan with the 99.99% probability. So it's very sure about this Catalan. You can also specify minus d. And this just means it will give you a distribution over all of the languages supported by the library. So and it's sorted by the probability. So in this case, we see, well, there's Catalan, and then Spanish is the next one, but the probability is also already very low. And let's just try this with multiple sentences, right? So it also has a batch mode. So we can just pipe the whole file into it. But we have to say something somewhere. No, not this thing. Minus line. So if we want to put in multiple lines which are in different languages, so we should say that is actually multiple lines, because otherwise it will just try to guess the language for the whole file, which, well, doesn't make much sense. So it actually guesses, I don't know what this is. let's see what that is. Okay, Quechua. I don't think actually this language is included in the file. I'm not sure. Uh, so it doesn't make much sense. But if we say, what was it? Lines, line. So now for each line in the file, we are getting well, a prediction of the language, and we don't see the lines now, so it's a bit stupid. So let's just look at it together with the lines. Okay, so Catalan, yeah. So this is obviously Hebrew. This again is some Catalan. Now this is Czech. This is Slovak. Hebrew again. Some Czech sentence again. That's fine. Now this is harder. So Article 3. It guesses English, which is probably correct, but the probability is quite low because, well, this could be in other languages probably. The text is very short, so it's fair to say that when the text is very short, it's just harder to guess the language, so the tool produces a lower confidence. This is the same here for Czech, where well, it's still 75%, but it's lower than 100%. And yeah, and sometimes it might be incorrect, which I don't know if we see here. See some Japanese, some Hindi, and yeah, I don't see any clear errors here. Yeah, well, this is actually Japanese, but you cannot tell because it just has the Chinese character, so it guesses Chinese, which could be correct. Then this is really weird. For this text, which is obviously in Slovak, it guesses Chinese. I would assume it's confused by the capital letters. So if you typically look at Slovak, it typically doesn't use all caps. So we can actually try this and see what happens if we lowercase it. So if I just run it like that, it guesses Chinese, and yeah, I have some lowercasing script somewhere. So let's see what happens when it's lowercase. When it's lowercase, it guesses Slovak correctly. So that's something like in the tone that I was saying. Always check the results. Always check whether they make sense to what you're doing. So here we know this is a state-of-the-art tool. It has a very high accuracy. But we just find out that the model isn't trained for capitalized texts. Well, that's typically reasonable, very reasonable, and very actually typical that some models assume that the text is lowercase. Some models just assume it's true case. So that's one of the reasons why you should always check your results. Yeah, and yeah, this funny cross, which look bad here and which look really nice here. So I wonder whether you figured out what that is. So we know the language code is HY, which you might or might not know what the language code means because the language is actually Armenian. But I guess in Armenian, the name of the language is something where it makes sense to call it this way. So that was language identification, and yeah, as I promised, I will pause for a while now so that you can, well, ask questions, or you can just try it yourself to see whether it works for you. So I'll wait a while and speak up if you need something. I'll pause the recording. So I hope I'm recording again. Yeah, it seems so. So one task is actually to identify which language the texts are in, and If you want to do some programming exercise at home, then you can just write some code to take something like the mix of languages and separate it into separate files by the language, which is something actually useful if you just want to scrape your data to build a corpus of some language. So it makes sense to scrape even websites which contain multiple languages. Like a lot of websites contain some English texts, so you want to get rid of those. And the next thing is Unidecode. Again, that's a library you can install in Python, and it also exists for Perl. And I think actually here it's just a port from Perl to Python. And so what it does is that it transliterates kind of nearly any characters into ASCII. I don't know if it seems you can also use it this way. Okay. I wasn't sure. So let's see what happens with the file. Yeah, it does do something. And again, we see just the transliterated thing and not the original. So it's not very nice. So again, I will just put it into a file and paste it with the original. And I'm using it from the terminal, but we can also import it in parallel. Maybe show it in Python. I can maybe show it as well. Okay. So and maybe how do I say the delimiter -d? I would like to see it line by line. Yeah, that's nicer. Okay. So Unidecode has some kind of interpretation of what it means to transliterate text. So it does it like independently for each character, and it converts the text to ASCII. So it like gets rid of these diacritics. For the Hebrew, it just translate to some characters which the letters correspond to. Uh, so for Czech, it gets rid of the accents. Where do we have something more interesting? Yeah. So for the Hindi text, so here it's hard to see with the combining characters to see how many characters there actually are. So if I just try it here, so it's 1, 2, 3 characters it seems, and it's translated into 5. So they try to uh, uh, interpret some syllables, some long vowels, things like that. So the text can be longer than the original text actually, but it's like kind of a reasonable guess of how you could uh, work with this text in ASCII. It's something you can try reading, and because I don't know Hindi, so I have no idea how accurate this is, but well, it's something useful, and it's at least like if you want to create a file name or something, then this works. Now this fun Armenian script, again, it does look like language after you transcribe it to ASCII. Uh, and yeah, so this is the, I don't know whether it's Russian or I think it's Ukrainian, this one actually. So this one is transcribed as 2 characters, but again gets rid of all the diacritics and everything. And fun thing happens with Japanese, because as you might know, Japanese has 2 Japanese scripts, and then it uses uh, Chinese characters as part of the text. So it does transliterate the Chinese characters as Chinese characters. So these are these capitalized words with spaces. These are the Chinese ones, and the Japanese ones, they are just transliterated in the Japanese way. So you get a weird mix, which doesn't make much sense. But that's because they decided that they don't look at the context; they just transliterate each character independently. So they have no other chance of doing anything else. And you can see they also transliterate the dot, like the Japanese dot, to the European dot, which is nice. Um, so so that's something. So obviously, when you do real linguistic work, you should, uh, I guess, always work with the original script, because this transliteration is always only some approximation. So in the olden days, people would build tree banks of Japanese with the transliterated Japanese texts, but that's not the correct way, I would say. But it helps a lot when you're just working with some language which you cannot even read. When we were, I don't know, working with Armenian, so like mentally it's very hard to look at that and think about this as words and see whether the words are the same or different and so on. So like for your eyes, it may be very helpful to transcribe it to something readable, uh, which, well, doesn't work, for example, much uh, for uh, for Hebrew, because, well, they don't usually write vowels, so it's hard to read anyway. But well, at least it's something. And here I actually have two tools for the same thing or for a similar thing. So if you do have access to the UFAL computational cluster or to UFAL network, then you can also try using Dan's script, which kind of does a similar thing, but it's based on different assumptions. So, for example, it doesn't assume that uh, all has to be in ASCII. It rather thinks that it's a good idea to use the whole variety of characters that we have available in Czech. So it's especially useful if you're a Czech speaker, because then it will look actually nicer than the output of Unidecode. Um, so in some cases it's very similar. Uses J instead of Y, but that's not a big difference. But it keeps the accents. And when I move to something different, so yeah, so here you can see the Hindi text, where actually it doesn't, it keeps the accents there. So in the Unicode, it just discards this information and just maps it to ASCII. And here you even so you get more information. On the other hand, well, wow, this is fun. So the Armenian looks even weirder. That's fine. On the other hand, Dan's script has, I guess, weaker support for scripts. So, for example, it seems it supports Chinese, and it has a better transcription, so you can also see the tones there. But it doesn't support Japanese. So, so here, this is even a weirder mix of transcribed Chinese characters intermixed with the non-transcribed Japanese ones. Uh, so so that's just two tools that do a very similar thing, and none of the tools is perfect, obviously, but both of them are good and useful. Um, so I'll stop the recording again for a while. Resume recording again. So the last thing I want to show is Unicode data library in Python. And again, there are similar stuff in Perl and other languages. So here it makes sense to look at the documentation, because I never remember the names. So most importantly, I want name and then look up. Okay. So uh, so you've seen how this stuff works already. So I'll import Unicode data. And So it tells you a name of a character. So for some characters, this is easy. This is not surprising. I can try some Czech characters. So again, probably not very surprising. The good thing is that I can even just copy paste something from the Hindi script, and so you can see it's a bit different than the transliteration. So it tells you something about what the characters are, but it's not the same as transliterating them. So we can try it with some part of the text, like if I just copy paste it. Yeah, Unicode is all about characters, so I cannot just put in multiple characters. It can just do one. But I can just do a for cycle over the text. Yeah. So you can see what's all there, and you can see that actually it uses these combining characters. So we see these funny circles here. Yeah, we can try the same with some other text. So yeah, actually this one is nice. So we can look at Hebrew. Yeah. So here you really see the names of all the characters. Doesn't mean that this is how they're read, of course. It's just a suggestion, but you can figure out what this is, and we can try one more with the Armenian. And yeah, so some things you can learn from Unicode. So this is good in one direction. Interestingly, it doesn't work very much for the Chinese characters, or well, it does work, but it doesn't really tell you anything useful. We can try this. So so for the Japanese characters, it makes a lot of sense to just well refer to how the character is read. But in Chinese, it's only an approximation. It depends a lot on how it's pronounced in various dialects, and then the Japanese again would pronounce it differently, and so on. So in Unicode, you don't get this information that you would get in the transliteration. So you don't get anything about how this is read or what this is. So you just get a different ID for that. So and obviously, uh, if you talk to somebody Japanese, so he would know what hiragana letter su is, but I guess no Chinese person would tell you what the unified ideograph for EBA is. So this is only marginally useful. And now we can go in the other direction as well. So there is the lookup function, where you put in this long description of a character and you get the character. So we can try it with, I don't know, some Japanese. So maybe if you're learning Japanese, then this is interesting way to find the characters. And well, as Dan showed, you can also have weird stuff like domino tiles. So this is all something that you can just paste in here. So if I want to have a different domino tile, so they're all there. Um, so if you ever think about implementing a game of domino in the terminal, then Unicode is your friend, and you can easily get all these tiles there. And yeah, it's hard to figure out these descriptions yourself. Yeah. Yeah. So there are various things that it makes sense to learn these terms that they use for that. Yeah. Uh, like for the Polish, they might be happy that this is the official term uh, is Polish for this mark. And yeah, as you can see, we are getting out of time. So just briefly, so the library can do all the other stuff that Dan basically explained in the slides. Uh, so that's all nice. It tells you the category of the string of the character. Not capital. So it's some letter, and if you uh, have some punctuation, so it will tell you it's punctuation, and importantly, again, it works for these various languages. So even if I take the Japanese dot, I get the same category. So that's nice. And I wonder what it tells me for the domino tile. Okay, maybe something like symbol. So all this information there, and you can do these normalizations and decompositions. That's all there. So I'll stop sharing and